Yes students, welcome to our second video lecture. In the first video lecture students, means the previous video lecture I mean to say, we have already discussed the types of functions. How many types of functions are there? Then the answer is three types of functions which are written again. One function, many function and constant function. And one important result, students, images of elements of domain are also called functional values. So what is the synonym? What is the other name of images? Then students, I can say functional values. Now students, in the previous lecture, exercise 8 section A, we have completed first 7 MCQs. 8 MCQ is not done because that concept, students, is still pending. 8 MCQ is not done, students, because that concept is still pending. Now, section B, we have done first 3 questions. Now, we are doing questions 4, 5 and 6 of section B. All of you please concentrate. Section B, students, first 3 questions we have done. So now we are doing questions 4, 5 and 6 of section B, students. Now what is the fourth question? Define one function in notation. Notation form or mathematical definition. Mathematical definition or notation, it is the same thing. Mathematical definition or notation is the same thing. Students, we have got an opportunity to revise the definitions. First, let us revise the formal definition of one function. Suppose f is a function defined from domain A to domain B. First, I am revising the formal definition in words. Suppose f is a function defined from domain A to codomain B. For any two different elements of domain, if their images or functional values are different, then such a function is called one function. I repeat, suppose f is a function defined from domain A to codomain B. For any two different elements of domain, if their images or functional values are different, then such a function is called one function. So we can write for a1 comma a2 belonging to A, where a1 is not equal to a2. If f of a1 not equal to f of a2, then f is called one function. So this is called the mathematical definition or notation form for one function. Now, in the fifth sum, they have asked the same for many. First, let us revise the formal definition of many one function. Suppose f is a function defined from domain A to codomain B. Suppose f is a function defined from domain A to codomain B. For any two different elements of domain, if the images or functional values are same, then such a function is called many one function. So, for a1 comma a2 belonging to a, where a1 not equal to a2. If f of a1 is equal to f of a2, then f is called many one function. So students, in the first three questions of section B again, we have got an opportunity to revise all the basic definitions of function. Answer 6 is the notation of constant function. So f is a function defined from domain A to codomain. Now, say for elements a1, a2, a3 up to an belonging to domain. So these are the elements of domain a1, a2, a3 up to a. Students, this notation form is not given in textbook, so all of you please try to understand. Concentrate. a1, a2, a3 belongs to up to a belongs to a, where a1 not equal to a2 not equal to a3 not equal to a. This means all the elements of domain are different, distinct or unique. What does this mean? a1 not equal to a2 not equal to a3 up to not equal to a is no two elements of a1 to a are same. If f of a1 is equal to f of a2 is equal to f of a3 is equal to f of a, then f is called a constant function. For all different elements of domain, if their images or functional values are same, for all distinct or different elements of domain, if their images or functional values are same, then such a function, students, is called a constant function. So this is notation or mathematical definition of constant function. This is mathematical definition of many one function, and this is the mathematical definition or notation of, you can say, one function. So once again, this is a thorough revision of the definitions, students, of types of function. Basically, in your syllabus, students, we have only 3 types of functions, and those types are one function, many one function, and constant function. Okay, we further continue, students, with section B, and then we start section C. Try to complete as many sums as we can of section B and, students, section C. Now, the 7th question is of equal function. We have not done. Let us do questions 8 and 9 of section B, which is based on types of function. Okay, so answer 8. F is a function defined from domain Z to codomain N. So here it is N. Sorry. And the functional rule is f of t is equal to t square plus 1. F of t is equal to t square plus 1 for every t belonging to Z. Is this function, means determine the type of function. Okay. Answer 9. F is a function defined from domain N to N. N means set of natural numbers. And f of t, the functional rule. Students, what is the functional rule? F of t is equal to t t square plus 1 where t belongs to n. In both these terms, students, we have to state the type of function. Means out of one random and constant, what is the type of this particular functions? That, students, we have to keep in mind. The main part of this type of sums is domain. Students, we have to concentrate on domain, because domain is the set of elements for which we have to obtain images. Domain, students, revise the definition of domain. Then, students, I can say that domain is the set of elements for which we have to obtain images. So, domain, answer is Z. Z is set of integers, I told you. So, whenever integers are given, same value you take positive also, and same value you take negative also. Suppose I take 2, then I have to take minus 2 also. Suppose I take 3, then I have to take minus 3 also. Because set of integers is either negative or 0 or positive. So at least 4 or 5 values we have to take. But I start with minus 2. F of minus 2 is minus 2 square plus 1. Replace t by minus 2, I am finding image of minus 2. Minus 2 square is 4, 4 plus 1, 5. Now take same value for positive, f of 2. So this will be 2 square plus 1, and that is 4 plus 1, 5. So whenever z is given, you take always in pair the same value with opposite sign. If you are taking 3, then take minus 3 also. If you are taking 4, then take minus 4 also. So element minus 2 is not equal to 2, but image of minus 2 is same as image of 2. So for two distinct elements of domain, their images or functional values are same. Therefore, according to definition, f is many one function. This is our final answer. So students, sums regarding type of functions are based on domain and corresponding images. Once again, sums of type of functions is usually based on domain and images. Now here the domain is n. Domain is n, and n is set of natural numbers which starts from 1. Here domain was set of integers which is there. So as far as sums of types of functions are concerned, students always focus on domain. And then students, we go one step forward. Now, first of all, I should start with image of 1. Image of 1 is 1 square plus 1. So 1 plus 1, 2. Image of 2 will be replaced t by 2. So 2 square plus 1. So 4 plus 1, 5. Image of 3 will be 3 square plus 1. Here replace t by 3. 9 plus 1, 10. Image of 4, if I find, it will be 4 square plus 1. So 16 plus 1 is 17. We check image of 1 is 2, image of 2 is 5, image of 3 is 10, image of 2 is 17. So for any two distinct elements, say 2 not equal to 3 and f of 2 is not equal to f of 3. F of 2 is 5 and f of 3 is 10. So for any two different elements of domain, their images are also different. Therefore, f is 1 function. This is our answer. So I told you generally a square indicates that it is a many-one function, but altogether it also depends on domain. Check, there is a square in 8 sum also, there is a square in 9 sum also, but in 8 sum the domain is z, set of integers, while in 9 sum the domain is n, set of natural numbers. So only square always does not indicate many-one, but along with square, domains are also an important criteria to decide the types of function. So this completes our section B in terms of types of function. Now students, section C, we do question 5 and 6. In section C, we do questions 5 and 6. Those sums were pending. Okay students, one by one, first of all, we do the fifth sum. Then students, we do the sixth sum. Okay students, sum number 5 of section C. Section C. Answer 5. Now, h is a function defined from x to y. First, let us collect the data. H is a function defined from domain x to codomain y. X is equal to t such that t belongs to z and minus 3 less than or equal to t less than or equal to 3, and y is equal to a such that a belongs to n and 1 less than or equal to a less than or equal to 20. Okay, and the functional rule is h of t is equal to t square plus 2. Again, we are to decide, students, what is the type of function. Again, students, here we are to decide what is the type of the function. So type of the function depends on the functional rule and the domain. Just now I told. So whenever we are discussing the sums of type of functions, domain is to be clearly understood. Domain is x and definition of x is this. T, this oblique line is read as such that t belongs to z means integer. T belongs to z means integer, and if you concentrate, students, on this condition, minus 3 less than or equal to t less than or equal to 3 means I have to write integers starting from minus 3 to 3 because equal to is there. So the integers starting from -3 to 3 are -3, -2, -1, 0, 1, 2 and 3. So this is actually called property method to write a set, and this is called listing method to write a set. I am slightly deviating from the topic. In your standard, you were taught that basically a set will be written in two different forms. The first is say listing method, and the second is say property method. So in short, your domain has 7 integers. -3, -2, -1, 0, 1, 2 and 3. In short, your domain has how many elements? 7. Now codomain. This is again the property method. Read it as A. Oblique means such that A belongs to n means natural numbers. 1 less than or equal to A less than or equal to 20 means I should write all natural numbers starting from 1 to 20 in codomain. I am not writing all. I am under the impression that all of you know to write natural numbers 1 to 20. So what is this specific? What is the specific value given? What is something specific about this question? Sorry students, then I can say that domain and codomain are written in property method which we have converted into listing method. Now it is very simple. Whenever you have an integer, always take a negative and positive value. So what is edge of -3? Then I can say -3 square plus 2, so 9 plus 2, 11. And what is image of 3? Then it is 3 square plus 2, so again 9 plus 2, 11. So for two different elements of domain, which are -3 and 3, -3 not equal to 3, but edge of -3 equal to edge of 3. For two distinct elements of domain, the images or functional values are same. Therefore, f is many one function. This is our answer. So I told you, whenever you have integers, you take same value with a positive sign, and students, you take same value with a negative sign. Only two values are to be checked. Even if I check -2 and 2, then also it is correct. 4 plus 2, 6 I will get. Or even if I would have taken -1 and 1, then I would have got 1 plus 2, 3, then also it is correct. No need to check for all values. A pair is sufficient. Okay, now students, we are doing question number 6. So, the specific approach to the sum was, or what was the peculiarity in the question? The domain and codomain were given in property form, which we first converted into listing form. And then students, we did the sum. Okay, question 6. H is a function defined from A to B. Answer 6. H is a function defined from domain A to codomain B. A is already given in listing method 1, 2, 3. And codomain is also given as 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Fair functional rule. h of x is equal to x plus 5. Again, we are to identify the type of function. So, students, domain is A. This is domain, and definitely this is codomain. Let us start evaluating the images of domain. H of 1 is 1 plus 5, 6. H of 2 is 2 plus 5, 7. H of 3 is 3 plus 5, 8. So images are different for different elements. So we can write like this: 1 not equal to 2, and h of 1 is also not equal to h of 2. So for two different elements of domain, their images or functional values are different. Therefore, according to definition, f is 1 function. That's all. So this sum is very easy, students, compared to the previous sum. In previous sum, we had to think a lot to convert the property method into listing method. Here in this sum, we do not have such constraint. Directly, domain and codomain are given in listing method. So, students, here question number 5 and 6 are completed. Now, the most important sum of section C, and that is sum number 11. F is a function defined from R to R. Answer 11, most important. F is a function defined from R to R, and the functional rule is x squared plus 2x minus 1. Functional rule is fx is equal to x squared plus twice x minus 1. Now here, domain and codomain are generalized, and R means set of real numbers, and this set possibly includes all types of numbers: natural numbers, integers, rational number written in the form say p by q, 2 by 3, irrational numbers like root 2, root 5. All types of numbers are there in R, and R means set of real numbers. So students, in this type of sum, how should we proceed? There is a simple but very interesting technique. From square term and linear term, power 1 means this is linear term. As far as the domain and codomain are generalized, take x common and write x plus 2 minus 1. Correct? Now what you have to do, equate this term to 0. On the side you show like this: x into x plus 2 is equal to 0. So either x is 0 or x plus 2 is 0. Therefore x is equal to 0 or x is equal to minus 2. This one should be right. This all of you know, that if a into b is equal to 0, therefore either a is 0 or b is 0. Or both. This all of you know. So you got two values, and those two values are 0 and minus 2. I box it. So what you should do, find images of these two values. So if I find image of 0, then I can get like this 0 into 0 plus 2 minus 1. What is 0 plus 2 is 2. 2 into 0 is 0. So image of 0 comes out to be minus 2. Now find image of minus 2. So here I write minus 2. Here I write minus 2. Plus 2 minus 1. Minus 2 plus 2 is 0. 0 into minus 2 is 0. 0 minus 1 is minus 1. So image of 0 is also minus 1 and image of minus 2 is also minus 1. So 0 not equal to minus 2 and f of 0 equal to f of minus 2. Two elements are distinct but their images are same. Therefore f is many one function. This is the answer. So this approach is to be followed when your domain and codomain are, you can say, general. And your functional rule is a quadratic. X squared plus 2x minus 1 is called a quadratic. The general form of a quadratic, all of you study ax squared plus bx plus c, where a not equal to 0 and a, b, c belongs to R. This is the general form of a quadratic polynomial or quadratic equation. So this is what, students, we have to understand. This approach is done when domain and codomain are generalized, especially R. R is set of real numbers. Suppose, students, my function was like this. Fx is equal to x squared minus 6x plus 11. What I have done? X into x minus 6 plus 11. Equate this to 0. So x into x minus 6 is equal to 0. So x is equal to 0 or x minus 6 is equal to 0. So x is 0 or x is 6. We have to find image of 0 and 6. So for which two elements image is to be found out is a very important criteria here. And that depends upon the first two terms of the functional rule. That depends upon the first two terms of the functional rule. So students, one more sum of type of function properties and expanded that will next time. Here we conclude the lecture. Thank you, students. Thank you so much.